Hello, Roger Liu here from the Virtual Technology Laboratory of the University of Idaho, and I'm here with the Virtual Cities for Unity 3D Tutorial 8. When we left off last time, we got our inhabitants of our virtual city to start paying rent. Since then, I've been kind of fiddling with a couple of things. I just wanted to show you some of the changes that I made to the time controller. Right now, we can specify the time scale, but if we go too fast, we'll not catch minutes, or we'll not catch hours, or we'll not catch days. So we might want to actually detect whether we're missing hour events or day events. And so basically what I have now is this step validation feature. So we can specify our error checking. So right now I have it set on hour. And so if you don't catch every single hour, so like say you go from hour 3 to hour 6, it will log in break. And I'll show you how that works right now. So right now we're running along at a time scale of 1 hour equals 1 second of wall time. If I increase this up to say 3, we're still not breaking. If I go to 4, okay, now we can see here it says time controller skipped 1 or more hours, and that's because and we've also gotten a pause. And that's basically because step validation is on hour, and I've told it that I want it to log, report in the console, and then break, put the editor into pause mode. If I change this to day, for instance, though, it will allow it to skip hours without complaining or pausing. Or alternatively, I could put this at hour and change this to log only. And now you can see that this error is reoccurring somewhat periodically. It's not skipping. It is not skipping on every single update, but periodically it'll skip 1 or more hours. So let's go ahead and take a look at the changes that I made to implement this. So inside of Notepad++, I've loaded up the old script and then the new script, and then I have a plugin so I can compare these. And essentially the way this works is lines that are green are additions. There's also plus signs here to kind of help point that out. And then yellow lines are where something has changed. So here, the default for the timescaler has changed from 1F to 4F. And then deletions are shown in red. So here, for instance, is a deletion. So I've taken this month equals find month, and I believe I actually moved this down. So we only need to find the month when our day changes. Otherwise, we don't need to check. And I did this because this find month algorithm is a little bit slow because it has to iterate up through the array. We talked about this before. But to show you the changes that were made, now we have 2 public enums, one for Timestep Validation, and then one for on-step validation failure. So this specifies the Timestep Validation. So when it's on none, it doesn't do any checking. If it's on minute, then it checks the minutes. If it's on hour, it checks the hour, and so on. And then on-step validation failure specifies what we want to happen. And then inside of our class, we declare an instance of these enums, and that way they'll show up. We make those public, and that way they'll show up in the inspector. And then if we move down, so it looks like here I added a space at the end, so that's why this is getting highlighted as yellow. And then if we move down, I already explained the month, and then here I am declaring this step val diff in the update scope, so I don't have to reuse it within each of these if loops. I can just define it once, and then if I need to use it, I can use it. So you can say This is representing the difference in minutes if we're doing a minute validation. And then if we're doing hour validation, it represents the difference in hours and so on. So basically, if the step validation is set to minute, then we take the difference from the current minute and the old minute, and we assign that to step val diff. And then if that doesn't equal 1 or negative 59, so in the case that this is 59, or sorry, in the case that this is 0 and this is 59, then we get 0 minus 59, we get negative 59. So this basically catches when it rolls over. In the case that step val does not equal 1 and step val does not equal 59, negative 59, then we log. And then if we're supposed to break, then we'll break. And there's the same sort of logic for each of these. That's basically how it works. And okay, let's turn our attention now to our primary task for this tutorial, and that is to give our humans jobs so that they can afford to pay their rent or their monthly mortgage. To give you a little bit of a recap, I have the resident script up, and the resident script is actually what is generating the humans in our virtual city. So depending on the residence type, the resident script will generate it'll generate 1 to 4 adults per residence, and it will generate 0 to 5 children per residence. The resident script also comes up with a monthly cost of the residence, and we need to figure out a way to give our humans jobs that kind of correlate to their social economic status. And to do that, let's turn our attention to our human script. And basically what we want is a job skill property that we can reference. So let's go ahead and create that. I'll call that, well, let's make it show only. And then will be a float, and we'll call it job skill. And it'll be normalized between 0 and 1. So, there's literally probably a bazillion different ways that you could come up with job skill. And what I want to do is have job skill based on their education, their intelligence, their experience, and lastly, something that we'll call Attainment Drive. And this can be like sort of like a drive for wealth, I guess. And I'm not saying this is a completely representative, truthful, accurate model of job skill. I'm saying this is how I'm going to do it. You can do it how you want. Ideally, we could base this on data or some sort of model, or some sort of empirically based model. But that's not really the point here. The point is to show you how you can implement it in code, and then as we go along, we can make our models more robust. So how are we going to do this? Well, to start, intelligence is actually probably the easiest thing to represent in our game. It's hard to, I guess, build artificial intelligence, but it's actually pretty easy to represent it. So I can create another attribute that will be a show only attribute. And this one we will call public float intelligence. And then in start, we can come up with a random intelligence that's completely independent of their age and human type and residence and everything else. So to do that, we can use our normal random method of the miscellaneous class that I showed you in a previous tutorial. And what this does is it returns a random number from a normal distribution given a mean and a standard deviation. And if we represent our intelligence as IQ, we know that humans have a average of 100 and a standard deviation of 15. So voila. And then the next thing we'll want to do is come up with a normed intelligence, a value that's between 0 and 1, just because it is a lot easier to deal with. So I'll create a public float normed intelligence. And here I'll actually show you something new. So before we were defining properties like this, or the attributes of the class like this. But this is actually sort of a shorthand for defining get and set methods. So what we actually want to do is take whatever this intelligence is and then calculate it on the fly and give it back. So what we can do is say that we want to return intelligence, or we have to actually type return intelligence minus 70, so that's 2 standard deviations below the mean, divided by 130f minus 70f. And then I'll want to clamp this between 0 and 1. And then I'll need a semicolon. And then I can't use a show only with a property defined in this manner, but there's another trick that I'll show you in a bit. So basically, I'm normalizing intelligence between plus 2 standard deviations above the mean and plus 2 standard deviations below the mean. Alright, so that handles intelligence. For experience, what I'm thinking is we can use age, and we could do that in much the same way as we're doing this. So we can do public float experience and basically I want experience normalized between, say, 18 and 65. So I would do age minus 18f divided by 65 minus 18. And that takes care of experience. And now we can do Attainment Drive. Attainment Drive I'm going to have based on the monthly cost of the residence. And we have those kind of hard-coded in these classes. And if you think about it, the cheapest possible cost would be if there's 2 people in an apartment. That's basically how it's set up right now. So that would be $275 a month. And then the highest possible cost would be $2,200 a month. So that'd be if you're a single person living in a suburb or in a condo. So we can just roughly normalize it between those values. So to do that, we'll need to do residence dot monthly cost 275f 2200f minus 275F. And again, the nice thing about doing it this way, defining the public properties with the get and set methods, is that over time people will age and their experience will go up because we're calculating this on the fly, and the same goes with their monthly cost, or with their attainment drive. So as their residence cost goes up, this gets calculated on the fly, and their attainment drive will go up, I guess. I guess we probably should come up with a way to use the actual lowest and highest costs as time goes on. But that's something that we can resolve later. We could even kind of like add a note in here to do that. Alright, so that takes care of Attainment Drive, and that just leaves us with Education. So to do that, let's take a look at this distribution of education year, our highest year of school completed. And so what we can see on the y-axis is the frequency, and then what we see on the x-axis is the highest year of school completed. And we can see that the mode is at 12 years, and that's because people basically go through kindergarten K through 12. I guess, yeah, that's actually kind of weird, because then you would think it would be 13, but yeah, I guess there you go. The nice thing about this is that this actually tells you that the mean is 13.36. I guess that makes sense. And then the standard deviation is 2.974. So we can actually use those to come up with a random education value. But we'll need to make sure that we're not assigning an 18-year-old 22 years of education. So when I do stuff like this, like normally what I want to do is copy or reference where I got the numbers from. So I'll just go ahead and do visit page and then copy the link and return to here. And so what we'll want to do is come up with a public float education. And I'll just make a note that this is in years. Actually, this one we don't need get and set methods. And then we'll actually want to set this in start. So we make a little note. Initialize education data from. Okay, so basically what we need to do is come up with a random number, and we would do that with miscellaneous.normal random, and then we would give it the mean and standard deviation from the figure, which is 13.36 and 2.974. So what we need to do is make sure that their education is less than their age minus 5, assuming that 5 is when they start their formal education. And we can do that using a while loop. So I'll type while, and then I put the condition in the parentheses. So I'll say education is less than age minus 5. What we want to happen if this condition is true is what goes in between the brackets. So actually, this is what we want to be true. So we want, we only need to come up with a new number if that was not true. So we actually want education greater than their age minus 5. Let's say this comes up with 22 years, and say that they're 18. So education is 22. and their age is 18, so 18 minus 5 is 13, so 22 is greater than 13, that's true. So then we would go into here, and basically we could keep redrawing a number, a random number, from the distribution until we get a number that makes sense. And then we'll come up with a normalized education value. And for the min, let's just go with 0, I guess. And then for the max, 19.5. So that's roughly 2 standard deviations above the mean. And then I need an F here. Okay, so now we have education, intelligence, experience, and attainment drive defined. And we can define a job skill get method that will essentially wait and return those. Okay, so yeah, that should work. And then it should be worth pointing out that we're kind of initializing their education here. But if say they're in college, then we would need to increment their education level. The same thing is true with their age. Right now, we're setting their age. Actually, their age is getting set when their human type is set. But we're not actually incrementing up their age. So that would be something that we would want to happen as well. So we could actually make notes of that. Okay, so I went to test it, and it took a really long time to start. And I think the reason is because of this code here. So for the children, we should just directly calculate their education. And then for the adults, we can do the sampling. But for the children, that code doesn't work so well because in the case that they're young, you're just relying on odds to come up with a number that makes sense, and it adds a significant amount of time to the startup. So here we can just calculate education as age minus 5. And we can see if that makes it a little bit quicker. Yes, so that was definitely quicker. So we can see that they have an intelligence, and they also have an education value. The education value should actually make a read only. But we can't see a lot of our other variables, the ones with the public get and set methods, and there's a trick to fix that. So before I forget, I want to make education show only. And then the trick to be able to see the properties in the inspector with the get and set methods is on the Unity wiki. Basically, we just need to create these classes. And then to get it to actually work, there's 2 other things that need to happen. One is in our human script, we need to add the expose property decorator to the properties that we want to expose. And the other thing is we need to create a custom editor script for our human component. So to begin, we'll just copy the exposed property, go to our human script, and then we'll want to expose job skill. I'm not worried about exposing normalized intelligence. Then we can expose experience and attainment drive, and I'm not worried about showing normed education. And then the next thing we'll want to do is create a human editor script. So I'll copy and paste this stub. And inside of Virtual City Scripts Editor, I'm going to create a human editor C# file. Make sure I have the right one open. Then I'll paste in the stub. And then I need to change my type to human. Then change the other references to my type to human. And then I'll change my type editor to human editor. And this essentially overrides how the human component is drawn in the inspector. So now if I did everything correctly, we should be able to see those attributes in the human component. Okay, so for this human, we can see that they have an intelligence of 106. They have an education of 9.5 years and job skills of 0.420411, experience of 0.4489, and attainment drive of 0.142. The way that these look aren't exactly the same as the way that the other read-only properties are. But if you really wanted to, you could go in and fiddle with the editor script, or the property attribute script. Alright, so we could start poking around and look at whether the variables we're assigning to our humans make sense. So the apartment dwellers, for instance, should have lower attainment than, say, the condo or suburb dwellers. Oop, that's downtown apartment. Where are my suburbs? They're up here. Oh yes, so these adults have higher attainment drive. We might want to create a more systematic way of assessing how these variables are distributed across our population of humans. And to do that, we could modify our human data dump script to spit out those additional properties. So in addition to name, residence, human type, and age, we'll want to add intelligence, education, attainment, drive, experience, and job skill. So we have age, then we'll have human.intelligence, then we will have human.education, human.attainment drive, human.experience, and human.job skill. Let's double check this. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 8, so that should be right as long as I didn't skip any. 8, 7, 6, 5, 4, 3, 2, 1, 0. And we can copy paste this. And then I'll go ahead and restart. generate a report. This is telling me the report has completed. And I'm going to select all the data and then go to pivot. Well, let's actually do a pivot chart. Right now I'm only interested in the adults, so I'm going to put that into filter. And then I can select only adults. And then let's go ahead and break them up by residence type. And let's look at so their intelligence should be the same. Well, that's showing some, so that would be related to the number of individuals in each. So our y-axis is deceiving us a little bit, but those are pretty much the same. You can see how job skills are distributed. Again, that's showing some, so we need to make sure we're on average. And then we might also want to look at min and max. Alright, so from here we could fiddle with the weights a little bit. I'm probably going to do that, and then in the next video I promise we'll actually get to implementing a workplace and getting our inhabitants of our virtual city employed. So until then, have fun with this.